Good morning. I am Roy Joseph B. Argumido, a BSCSG student. I will now discuss the definite clause grammar or the DCG under the topic agents that communicate. There are two problems with the BNF. First, we are interested in using language for communication. So, we need some way of associating a meaning with with each string, and BNF only talks about strings, not meanings. Okay. Second, we will want to describe grammars that are context sensitive, whereas the BNF or the Bacchus Naor form is strictly context free. In this section, we introduce a formalism that can handle both of these problems. Each non-terminal symbol becomes one place predicate that is true of strings that are places of the category. So we are introducing now the first order logic. So for example, the noun stench is a true logical sentence, whereas the noun they is false. It is easy to write BNF rules as logical implication sentences in first order logic, as can be seen in the slide. So the first rule says if there is a string S1 that is a noun phrase and a string called S2 that is a verb phrase, then the string formed by appending them together is a sentence. The second rule says that if S is the string stench or one of those words not shown, then the string is a noun. A grammar written with logical sentences is called a logic grammar. Since unrestricted logical inference is computationally expensive, most logic grammars insist on a restricted format. The most common is the definite clause grammar, or the DCG, in which every sentence must be a definite clause. A definite clause, by the way, is a type of foreign clause that, when written as an implication, has exactly one atom in its consequent, and a conjunction of zero or more atoms in the antecedent. The DCG formalism is attractive because it allows us to describe grammars in terms of something we understand well, that is, the first logic grammar. With the use of DCG, we could easily describe grammars. Unfortunately, it has the advantage of being more verbose than the BNF notation. So verbose means it has more words used than the BNF. Okay, so we can have the best of both by defining a special DCG notation that is an extension of BNF but retains the well-founded DCG semantics. Okay, from now on, when we say definite clause grammar, we mean a grammar written in this special notation which is defined as follows. As you can see in the slides, there are three rules in the DCG. First, these three rules allows us to translate BNF into definite clauses. We now see how to extend the notation to incorporate grammars that cannot be expressed in the BNF. Again, BNF is Bacchus Naor form. The rule 1 says that non-terminal symbols can be augmented with extra arguments. In simple BNF notation, a non-terminal such as NP gets translated as a one-place predicate where the single argument represents a string or the NP, then inside of it is the S. And in augmented DCG notation, we can write NP then the sum. For example, to express an NP with semantic sum, this gets translated into logic as the two-place predicate NP sem, comma, S. The next rule says, a variable can appear on the right-hand side of a DCG rule. This variable represents a single symbol in the input string without saying what it is. We can use this to define the non-terminal category double as a set of strings consisting of a word repeated twice. So, pag sinabi natin double, so it represents a set of strings that is repeated twice. Here is the definition in both DCG notation and the normal first-order logic notation. The last rule says that an arbitrary logical test can appear on the right-hand side of a rule. Such tests are enclosed in curly braces in DCG notation. As you can see on the slide, that explains what is under the rule number 3 of the DCG. As an example, using all three extensions, here are rules for digit and number in the grammar of arithmetic. The non-terminals take an extra argument representing their semantic interpretation, as you can see in the next slide. Okay, the first rule can be read as a phrase of a category, digit, and a semantic value, sem, that can be formed from a symbol sem, and it is between 0 and 9. So that is the digit. The second rule says that a number can consist a single digit and has the same semantics as that digit. The third can be read as saying a number with a semantic value. Sem can be formed from a number with a semantic value, sem, followed by a digit. It is followed by a digit with a semantic value sem minus I, where sem is equals to 10 multiplied by the first sem plus the second sem. Okay. So, to clear things out, there are now 5 things that can appear on the right-hand side of a rule in this notation. So, you can see in the slide, an augmented non-terminal digit, as stated a while ago in the rule 1. Next is an augmented non-terminal digit sem, a variable representing a terminal sem, a constant terminal word or the variable, or a logical test. For example, as given earlier, 0 is less than sem while greater than 9. So it is between 0 and 9. The left-hand side must consist of a non-terminal with or without augmentation. So as you can see in the slide, so it is clearly stated on the table that what I have explained is present on the table. Okay, the next topic is augmenting a grammar. It is also in the same topic, the agents that communicate. So, the simple grammar generates many sentences of English, but it also overgenerates, meaning it generates sentences that are not grammatical. For example, me smells a stench. There are 2 problems in this sentence. It should be I, not me, and it should be smell, not smells. To fix these problems, we will first determine what the facts of English are, and then see how we can get the grammar to reflect the facts. Okay. Many languages divide their nouns into different cases depending on the role in the sentence. Pronouns like I are in the subjunctive or the nominative case, and pronouns like me are in the objective or the accusative case. Many languages also require an agreement between the subject and the main verb of a sentence. That is what we call the subject-verb agreement. Here, too, the distinctions are minimal in English compared to most languages. All verbs except be have only two forms. The first form, or for example, smells, goes with a third-person singular subject such as he or the wumpus. The other form, for example, smell, goes with all other subjects such as I, you, or wumpuses. Now, we are ready to fix our grammar. We'll consider noun cases first. The problem is that with the distinctions we have made so far, for example, the non-terminals, we have the determinant. Okay. English is not context-free. It is not the case that NP or a noun phrase can combine with a VP or a verb phrase to form a sentence. Okay, for example, the noun phrase I can, but me cannot. If you want to stick with a context-free grammar, we will have to introduce new categories such as the NPS or the noun phrase singular and the NPO or the noun phrase objective case respectively. So we also need to split the category pronoun into two cases or categories. The first is the pronoun as or the pronouns, which includes I, and the pronoun no or pronoun o, which includes me. That states for the pronoun singular form or the subjective, and the pronoun o, which is the objective or the accusative case, which includes me. As you can see the table, notice that all NP or the noun phrase rules are duplicated. Once for NPs and once for NPOs. So NPS stands for the noun phrase singular form, and the NPO or the noun phrase objective case. It would not be too bad if the number of rules doubled once, but it would double again when we change the grammar to account for the subject or the verb of the agreement, and again the next distinction. Thus, the size of the grammar can grow exponentially with the number of distinctions we need to make. An alternative approach is to augment the existing rules of the grammar instead of new rules. The result is a concise, compact grammar, as you can see in the slide. It is a table has been given to express or display the use of augmentation. We start by parameterizing the categories NP and pronoun so that they can take a parameter indicating their case. So, in the rule for S, the NP must be in the subjunctive case, whereas in the rules for the VP, PP, and the NP, or the verb phrase, pronoun phrase, and the noun phrase, must be in the objective case. The rule for the noun phrase takes a variable as its argument. This use of variable or avoiding a decision where the distinction is not important is what keeps the size of the rule set. So, ibig sabihin nun, pwede natin ma-manage yung rule. So, hindi siya mag-grow exponentially. Yun. So, the problem of the subject-verb agreement could be handled with augmentations. It could be also handled with augmentations, as I said. So, however, we will discuss a slightly harder problem, which is is the verb subcategorization and under the same topic, agents that communicate. The first grammar language is an improvement over the grammar zero that we have previously discussed in the past topics, but it still allows ungrammatical sentences. One problem is the way verb phrases are put together. We want to accept verb phrases like give me the gold and go to 1, 2. All these are in the grammar 1 or the first grammar. But unfortunately, so are go me the gold, which is grammatically incorrect. Okay, so the proposed solution for this is to eliminate this by stating which verbs can be followed by which other categories. So we call this the verb subcategorization or the subcategorization information for the verb. Each verb has a list of complements or the obligatory phrases that follow the verb within the verb phrase. So, in the example, give the gold to me, the noun phrase, the gold, and the pronoun phrase, to me, are complements of give. So, a subcategorization list is a list of complement categories that a verb accepts. So, give has a subcategorization NP, PP, or the noun phrase followed by the pronoun phrase. In this example, it is also possible for a verb to have more than one subcategorization list, just as it is possible for a word to have more than one category, or for a pronoun to have more than one case. In fact, give also have the subcategorization list NP, NP. So that stands for the noun phrase followed by a noun phrase, as in give me the gold. So we can treat this like any other kind of ambiguity. So magulo. So it is also important to know what subcategorization list a verb does not take. The fact that give does not take the list PP or the pronoun phrase means that give to me is not itself a valid verb phrase. Diba? So, give to me. So, hindi naman yung valid na verb or action word or action phrase. So, the next figure, the next slide, gives us some examples of verbs under subcategorization list or subcats for short. Okay. So as you can see in this slide, so you could see an example of verbs with their subcategorization frames. Okay. To integrate verb subcategorization into the grammar, we do three things. First step is to augment the category VP or the verb phrase to take a subcategorization argument that indicates the complements that are needed to form a complete verb phrase. This gives us the rules as can you see on the slide. For example, give can be made into a complete verb phrase by adding the clause NP followed by a PP or the noun phrase followed by a pronoun phrase. So, give the gold, for example, can be completed by adding a pronoun phrase and give the gold to me is already complete. It is categorization list. Diba? So, as you can see in the step 1, so, the noun phrase can be followed by a pronoun phrase. So, pag sinabi natin, give the gold, so pwede natin siyang dagdagan ng pronoun phrase or pwede natin mag-augment ng phrase na to me. So, the clause NP followed by PP or the noun phrase followed by the pronoun phrase, give the gold to me is already complete. Diba? So we could find the subject and the verb. Okay. As you can see on the slide again, the first line can be read as a verb phrase with a given subcategorization list or subcat list can be formed by a verb phrase followed by a noun phrase in the objective case. As long as that verb phrase has a subcategorization list that starts with the symbol NP. So, pwede lang daw dugtungan o augment yung verb phrase given that it must be followed by a noun phrase. The second step is to change the rule for S to say that it requires a verb phrase that has all its complements, thus has a subcategorization list. Okay. So, sabi, this means that, for example, he died is a legal sentence, but you give is not. Diba? He died because there, he stands for the noun phrase, while died is for the verb phrase. So, it's a legal sentence. It's a valid sentence, rather. But you give is not. Diba? The new rule can be read as a sentence can be composed of a noun phrase in the subjective case followed by a verb phrase which has a null subcategorization list. So a figure will be represented later that shows a parse tree using this grammar. The last step is to remember that in addition to complements, verb phrases and other phrases can also take adjuncts. Adjuncts means phrases that are not licensed or registered by the individual verb but rather may appear in any verb phrase. So, phrases representing time and place are adjuncts because almost any action or event can have a time or a place. Okay, for example, the adverb now. In I smell a wampus now. And the pronoun phrase on Tuesday. So in give me the gold on Tuesday are adjuncts. So there are two rules to follow. Okay. So notice that we now have two rules, diba? With a verb phrase and the pronoun phrase on the right hand side, one as an adjunct and one as a complement. This can lead to ambiguities again. As discussed earlier, may kalituhan pa rin. So this can lead to ambiguities. Ika nga. For example, a walk Sunday. So, diba, is usually interpreted as an intransitive verb phrase followed by a time adjunct, meaning I move myself with my feet on Sunday. But if Sunday is the name of the dog, then Sunday is a noun phrase, complement. Diba? So, the meaning is that I took the dog for a walk at some unspecified time. So, the next slide, we can see the parse tree. For the example, give me the gold, showing the subcategorization list of the verb and the verb phrase. Okay, so we'll discuss the next topic, the generative capacity of augmented grammars under the same topic, agents that communicate. Okay. Generative capacity of augmented grammars. Excuse us. The generative capacity of augmented grammars depends on the number of values for augmentations. If there is a finite number, then the augmented grammar is equivalent to a context-free grammar. If we replace each rule schema with a complete set of rules, then we may end up with a finite, although perhaps exponentially large, set of context-free rules. But in the general case, augmented grammars go beyond context-free. To see this, consider each augmented rule as a rule schema. Okay, a rule schema stands for a set of rules, one for each possible combination of values for the augmented constituents. Okay, so if we replace each rule schema with the complete set of rules, so we may end up finite, although perhaps exponentially large set of context-free grammars. So pag pinalitan natin daw ng rule schema ng complete set of rules, so meron pa rin magkakaroon pa rin tayo ng finite o mabilang, although perhaps malaki na siya na set na rules. So but in the general case, augmented grammars go beyond context-free. So this ends my presentation of the DCG topic under the agents that communicates topic. So thank you for listening to me. So I am Roy Joseph B. Argumido again, and thank you for listening.